In this video, we'll review how to do long division of polynomials. Long division of polynomials is helpful to find either the factors of a polynomial, the roots of a polynomial, or the x-intercepts of a polynomial. To begin, let's start by talking about the fundamental theorem of algebra. The fundamental theorem of algebra says that the number of roots of a polynomial is always equal to the degree of the polynomial. So if you have a cubic function, which is a third-degree polynomial, then there has to be 3 roots to the polynomial. Again, the roots always equals the degree. Now, please be aware that the roots are not always equal to the number of x-intercepts. You can have a function that has imaginary roots, and the imaginary roots will not be x-intercepts. However, the degree will always equal the number of roots. We also need to review the remainder theorem. The remainder theorem says, given any polynomial f of x, if f of a equals 0 when you substitute, then x minus a has to be a factor of the polynomial. Conversely, if f of x is the polynomial and f of a does not equal 0 when you substitute, then x minus a cannot be a factor. This means if I have some polynomial f of x, and I substitute 3 in, and I get that f of 3 is 0, then x minus 3 has to be a factor of the polynomial. If I substitute 5 into the polynomial, and f of 5 does not equal 0, then that cannot be a root, which means that the factor cannot be x minus 5. Okay, putting this together, we can now talk about the long division. If we complete the long division of our polynomial and we get a remainder of 0, then the divisor is a factor of the polynomial. So when we do long division, we're going to look for a remainder of 0. If we get a remainder of 0, then we found a factor of the polynomial. Now let's take a look at an example here. In the first problem, we're told that x plus 5 is a factor of the polynomial f of x equals x cubed plus 4x squared minus 11x minus 30. And we need to find the other roots. Well, I know if one of the factors is x plus 5, one root is x equals negative 5. But I need to find the others. So we'll set up our long division. We're going to divide the quantity x plus 5 into the quantity x cubed plus 4x squared minus 11x minus 30. To do this, I need to look at x times what makes x cubed. Now I know that x times x squared is x cubed, so that's going to be the first part of my quotient. Now I'll multiply the x squared times x plus 5 and see what I get. X squared times x is x cubed, and x squared times 5 is 5x squared, and I'm going to write those down below. Make sure you line up the like terms. The x cubes need to line up, and the x squareds need to line up. I'm going to wrap these in parentheses, and now subtract. This becomes x cubed minus x cubed, and 4x squared minus 5x squared. X cubed minus x cubed is canceled to 0, and the 4x squared minus 5x squared is negative 1x squared. We now bring the next term down, which is the negative 11x. The next piece of the quotient will be found by going x times what makes negative x squared. I know that x times negative x would be negative x squared, so that's the next piece of the quotient. Multiply the negative x times the quantity x plus 5, and you get negative x squared minus 5x. Wrap these in parentheses and subtract. This becomes negative x squared plus x squared, and negative 11x plus 5x. Negative x squared plus x squared cancels, and the negative 11x plus 5x becomes negative 6x. Bring down the next term, and start again. I know that x times negative 6 makes negative 6x, and then I know that negative 6 times 5 is negative 30. Wrap these in parentheses, and again subtract. This becomes negative 6x plus 6x, which cancels, and negative 30 plus 30, which again cancels. If they both cancel, then the remainder now is 0. The remainder of 0 tells me that yes, x plus 5 was a factor, but I was also told that at the beginning. I can now write the factored form of the polynomial. I know that x plus 5 is a factor, and it gives you the quotient of x squared minus x minus 6, which means f of x can be rewritten as the quantity x plus 5 times the quantity x squared minus x minus 6. Now I need to see if I can factor out my quotient a little bit more. And because this is a trinomial, I can use one of the diamonds and say, well, what numbers multiply to be negative 6 and add to be negative 1? That would be negative 3 and 2, which means I can rewrite this as the quantity x plus 5, and now times the quantity x minus 3 times quantity x plus 2. This would be the fully factored form of the polynomial. I can use the factored form to now find the roots. If x plus 5 equals 0, then one of the roots is negative 5. If x minus 3 equals 0, then one of the roots is 3. And if x plus 2 equals 0, the last root is negative 2. And those are the three roots because this, again, is a cubic function. The fundamental theorem of algebra says the number of roots has to equal the degree of the polynomial. Now let's take a look at another example. In this example, we're told that negative 6/5 is a root of the polynomial. If negative 6/5 is a root, that means x equals negative 6/5. To find the factor, I need to move the negative 6/5 to the other side, and I'll do that by adding 6/5 to both sides, in which case x plus 6/5 equals 0, or I can multiply both sides by 5 and say 5x equals negative 6. Moving the 6, I get this. Because 5x plus 6 is now the factor, I can use this to do my long division. Now again, if you didn't want to do in the steps, you could have multiplied both sides by the, you could have moved the 6/5 and then multiplied it out. Multiplied by 5 on both sides, and you would have got the 5x plus 6 also. Okay, again, now we're going to set up the long division, and we're going to say what is the quantity 5x plus 6 divided into the quantity 20x cubed plus 24x squared minus 125x minus 150. Starting our long division, we know that the 5x times, it had to be 4x squared to make 20x cubed. Multiply the 4x squared times the quantity 5x plus 6, and you get 20x cubed plus 24x squared. Again, make sure you're lining up your like terms. We'll wrap these in parentheses, and now subtract. 20x cubed, and this becomes minus 20x cubed, is 0, and the 24x squared minus the 24x squared will also be 0. So we get a remainder of 0 there. So I need to bring down the next two terms now, because I always want to work with two terms when I have a binomial here. So I'll bring down the negative 125x, and I'll bring down the negative 150. I know that 5 times negative 25 is negative 125x, and 6 times negative 25 is negative 150. We'll wrap these in parentheses, and again subtract. Negative 125x plus 125x is 0, and the negative 150, and then it becomes plus 150, is also 0. So again, these cancel, and the remainder is 0. We can now rewrite the polynomial as saying f of x equals the quantity 5x plus 6 times the quotient, which is the 4x squared minus 25. I need to see if I can simplify my quotient a little bit. And I can, because I recognize the 4x squared minus 25 is a difference of squares. I know that can be rewritten as the quantity 2x plus 5 times the quantity 2x minus 5. Now this is the factored form of the polynomial. I can then use the factored form to find the roots. If 5x plus 6 is one of the factors, then I can say that 5x plus 6 equals 0, and the 2x minus 5 equals 0, and the 2x plus 5 equals 0. Using these, I can now solve to find the roots. If 5x plus 6 equals 0, then 5x equals negative 6, and then divide. I get x equals negative 6/5. On the 2x minus 5 equals 0, add 5 to both sides, 2x equals 5, or x equals 5/2. And on the last one, subtract 5 from both sides, 2x equals negative 5, divide both sides by 2, and you get now that x equals negative 5/2. Again, this was a cubic function, which means I should see 3 roots. Now we're going to take a look at one last example, and this one is a little bit tougher. In our last example, we're given that 2i is a root. This is an imaginary root. Now you have to remember that all imaginary numbers come in pairs. If one root is 2i, then another root would have to be negative 2i. Again, imaginary solutions come in twos. You always have the plus and minus values. Now I need to expand this back into a factor. I know that these are the roots, and I need to find the factor that produces those. Now there's a couple different ways to do this. If x equals 2i, I could move the 2i to the other side and get a factor. I could subtract 2i from both sides and say that the factor is x minus 2i. And on the other one, I'd add 2i to both sides, and I get x plus 2i. I could then multiply those factors out and get something that's no longer imaginary. Or I can think of it like this. If x equals plus or minus 2i, square both sides, and then x squared equals negative 4. I know it's negative 4 because 2i times negative 2i is negative 4. Building this out, I can move the 4 to the other side now by adding it to both sides, and I get the x squared plus 4 equals 0. That's one of the factors. Now I can use long division to divide that into the polynomial. Now this one you have to be a little bit careful. X squared and plus 4 are not in descending order with any gaps. There's a gap here. I don't see an x term. So when I do this, I've got to watch my like terms. I know that x squared times x is x cubed. So the first part of my quotient is x. But when I multiply this out, x times x squared is x cubed, but 4 times x isn't going to be an x squared, it's 4x. And I need to line the 4x up with the like terms. So it's going to go here. I'm going to wrap these in parentheses, and I'm going to subtract. X cubed minus x cubed cancels, and the 4x minus 4x cancels. Which means when I bring down the next piece, I've got the negative 3x squared still. Because I have a binomial in the divisor, the x squared plus 4, I need to work with another binomial, which means I'm going to bring down the minus 12. I know that x squared times negative 3 would be negative 3x squared, so that's the next piece of the quotient. Negative 3 times x squared is negative 3x squared, and negative 3 times 4 is negative 12. I'll wrap these in parentheses and subtract. And I'm going to see that both of them cancel. Negative 3x squared plus 3x squared is 0, and negative 12 with what becomes plus 12 also cancels. And we get a remainder of 0. This means that I can rewrite the polynomial x cubed minus 3x squared plus 4x minus 12 as the quantity x squared plus 4 times the quantity x minus 3. Now x squared plus 4 I can't really factor using non-imaginary numbers, so instead I'm just going to go and solve it. I know that x squared plus 4 equals 0 and that x minus 3 equals 0. This is using the zero product property. Now I could solve out x squared plus 4 equals 0, but really I've already done it above. I know that if x squared plus 4 equals 0, x squared equals negative 4, or x equals plus or minus 2i. Solving the other piece, I get that x equals 3. Now for the last time, this was a third degree polynomial, which by the fundamental theorem of algebra tells me it has to be 3 roots. And I do have them. I have positive 2i, I have negative 2i, and I also have positive 3. Alright, thank you for watching this video, and I hope that it helps you to understand how to do long division of polynomials.